Hey there, Samantha here with another YouTube video with SM NCLEX reviews. Today we're going to be talking all about MedMath. And I remember those grueling MedMath exams that you had to get 100% on at the start of every single semester. And these concepts extend beyond that quiz. You can absolutely see MedMath on your exams throughout the year as well as on your next gen NCLEX. So break out our small calculators and let's get going. I think to start out any conversation around MedMath, we first need to remember our conversions. Being able to convert pounds to kilograms or milliliters to teaspoons will be essential to get you through these questions. And while you do get a calculator on your exams, you won't get a sheet of conversions. So let's quickly do a matching exercise over just a few of these. Match the following values to their equivalent conversions. Go ahead and pause this video to write down your answers and then press play when you're ready. We have A, 1 ounce, B, 11 pounds, C, 5 milliliters, and then our answer choices there are 5 kilograms, 1 teaspoon, or 30 milliliters. All right, so weight is always a big one to know, so let's start there. Remember that 1 kilogram is equal to 2.2 pounds. And if you didn't know that already, definitely commit that to memory. So 11 pounds divided by 2.2 will match with A, 5 kilograms. Next up is 1 teaspoon. We know by process of elimination that the answer is either 1 ounce or 5 milliliters. So basic conversion-wise, 1 teaspoon is equal to 5 milliliters. And let's think about that. 1 teaspoon is pretty small, right? So visualize that in your head and that can help you with these questions. Picture a small syringe drawing up 5 milliliters and then seeing if that would fit into a teaspoon. And that leaves our last conversion. 1 ounce is equal to 30 milliliters, which makes sense if you think about feeding a baby a 1 ounce bottle. They're definitely going to get more than a teaspoon there. And if you don't have conversions down pat yet, make sure you refresh on those before your exams. These are great flashcard items. After knowing our conversions, it's all about setting up our equations correctly and reading the questions carefully. We need to pay close attention to the units of measurement and timing given to us versus what they want in the answer, because a lot of times it's going to be different. And what do I mean by that? So I see a lot, the question is giving you the amount per day and then asking you how much to give with each dose. And really, I think the easiest way to get MedMath down is just to practice, practice, practice. So let's go ahead and do a practice question. A client is receiving total parenteral nutrition, or TPN, through a central venous catheter. The provider ordered the TPN infusion to run at 24 milliliters per kilogram per day. The client's most recent weight is 176 pounds. What will the registered nurse set the hourly infusion rate at? Now let's pause here for a second. I actually see 2 big conversions we'll need to do for this question. Do you know what those are? First, we're going to need to convert their weight from pounds to kilograms and figure out the dosage per day. Then we need to solve for that hourly infusion rate. So before we do this whole question, let's first determine that weight in kilograms. Remember I said earlier, 1 kilogram is equal to 2.2 pounds. So we can just divide his weight of 176 pounds by 2.2 to get what? 80 kilograms. And now we can figure out that daily dosing. If we have 24 milliliters per kilogram per day, we can simply multiply 24 by the number of kilograms our client is. So 24 times 80 equals 1,920 milliliters per day. Now let's go back to our practice question. So I'm going to reread this here for you. A client is receiving total parenteral nutrition, or TPN, through a central venous catheter. The provider ordered the TPN infusion to run at 24 milliliters per kilogram per day. The client's most recent weight is 176 pounds. What will the registered nurse set the hourly infusion rate at? Round to the nearest whole number. Is it A, 80 milliliters per hour, B, 106 milliliters per hour, C, 160 milliliters per hour, or D, 1,920 milliliters per hour? Alrighty, we already solved for that daily infusion, and that's 1,920 milliliters per day based on this client's weight. However, now it's time to solve for that hourly rate. And don't overthink this one, you all. Simply divide the total amount by 24 to get it per hour. It's just that simple. So 1,920 divided by 24 is going to give us our rate of 80 milliliters per hour. And on the slide here, you can see how I would write this equation out on my scratched piece of paper during my exam. Remember, it's all about safety. Safety in medication administration is huge and not something to take lightly. Remember all of our rights of medication administration? Right dose is one of them. And double and triple checking that our doses are right is crucial to client safety. Remember, you are the last final check prior to administering medications to our clients. Now, while I hope this never happens to you as a diligent and safe registered nurse, let's do a quick bonus question over medication errors. During a shift change, a registered nurse realizes that a medication error occurred during the previous shift, and a client received an incorrect dosage of a critical medication. The client shows no adverse reaction so far. What is the nurse's immediate course of action? A, document the incident and monitor the client for any adverse effects. B, notify the nursing supervisor and blame the previous shift's nurse. C, administer the correct dose of the medication immediately. D, disregard the error since the client is not showing adverse effects. All right, you all. The correct answer is absolutely A, document the incident and monitor the client. While we may need to notify our supervisor or the provider, we don't necessarily want to shift blame onto another nurse. So we absolutely need to provide the right documentation and let the appropriate parties know that the client is safe. Now let's do one more equation. So this one's going to be over drip rates. And I remember being so overwhelmed at the thought of drip rates when I was learning them. But let's go ahead and break this down simply. So sometimes IV fluids need to be hung by gravity, and we need to make sure that the infusion is going at the right rate. And really, looking at your packaging of your tubing, you're going to find all the pertinent pieces you need to solve for that equation. The packaging is going to tell you how many drops there are per milliliter. So, a registered nurse is hanging in intravenous fluids to gravity for a client in the emergency department, as there were no more pumps due to unit acuity. The tubing package states it delivers 20 drops per milliliter. The ordered IV infusion rate is 125 milliliters per hour. How many drops per minute would the registered nurse count to ensure an appropriate infusion rate? Round to the nearest whole number. So, what is the first step to solving this? Since we have the drops per milliliter and the milliliters per hour, first I would figure out how many drops will occur per hour. So 20 times 125 means that there are going to be 2,500 drops per hour. And then we can look at what the question is really asking, which is drops per minute. So let's go ahead and solve this one, and let's read that question again. So the tubing packaging states it delivers 20 drops per milliliter. The ordered IV infusion rate is 125 milliliters per hour. How many drops per minute would the registered nurse count to ensure an appropriate infusion rate? Round to the nearest whole number. Is it going to be A, 9 drops per minute, B, 41 drops per minute, C, 42 drops per minute, or D, 104 drops per minute? You are all ready for your med math questions on your exams, I can tell. So we already had solved for 2,500 drops per hour. So to figure out the by minute dosage, we can just divide that by 60 and get our drops per minute rate. So when you do that, the calculator comes out to 41.6, but the question states us to round to the nearest whole number, so that's going to be 42. And here on the slide again, you can see some of the work of how I set this up. You are all rocking this. Thanks for joining me today. We are going to be launching some more MedMath here in the coming weeks. And of course, make sure you hit subscribe here on our YouTube channel so you don't miss out on those. Make sure you also check us out on our other platforms like Instagram and TikTok, where we also host some other live question breakdowns and content review there. We are rooting for you and happy studying, everyone.